So number 26 says, what is the absolute max and the absolute minimum? So let's underline these words here. Absolute max, absolute minimum of this function f of x on this closed interval. So absolute extrema with a given closed interval means we can use the closed interval method. Okay, so that's good because that's the most direct path to finding absolute extrema. So our function, I'm going to write this down again to give us a good starting point. So it's x to the fourth plus 4 pi cubed times x plus 1. Now, a really common thing that trips people up on exams is when pi and e are used as constants and don't have any variables attached to them. So pi is a number, okay? So we have to treat it like a constant for the purposes of taking the derivative. So 4 pi cubed is actually the coefficient of this term. So when you're taking the derivative, be careful and mindful of that. So otherwise it really messes up the algebra if you don't account for that properly. So the derivative of x to the fourth is 4x cubed. The derivative of this term is 4 pi cubed times the derivative of x, which is just 1. The derivative of 1 is 0. So this is the derivative, all right? Then we have to find any critical values. So the two types of critical values are where f prime does not exist. There won't be any. Remember, when we look for the D&Es, we're asking the same 3 questions that we ask when we're trying to find the domain of the function. Essentially, we're going, are there any variables of x that would break this function? So we check, are any denominators that might end up being 0? Are there any radicals where we might get negative numbers where we're not supposed to? And are there any log functions where we might get negatives or 0 where we're not supposed to? So if you've got no fractions, no logs, no radicals, you can very confidently just go none, okay? Then we also need to look for, are there any places where the derivative is 0? So we're going to set this equal to 0. I see both terms have a 4 in them, so I'm going to divide the whole equation by 4. All right, and then we want to solve for this, so x cubed. Oh, I did it again, y'all. I did this on my practice key, and then I did it again. I just, for some reason, want to make that a plus sign. The function said it was minus. It's a minus. It's a minus. It's a minus. So that also brings me to be very careful when you're copying a problem down. Double check before you start doing your calculations. It's a human error thing. It's so easy to copy something down wrong. So make sure before you, don't do what I just did. Make sure you verify that you've copied things down correctly. Okay, so x cubed minus pi cubed means that x cubed equals pi cubed, and we just simply take the cube root of both sides. Now for odd roots, you don't have to worry about getting multiple answers. Odd roots give one solution. If it's an even root, you have to account for the fact that there are 2 possible solutions. So we have an odd root here, so this is straight up x equals pi. All right, now we need to verify, is this critical value in our integral? Or interval, I should say. Well, pi is about 3.14. So 3 and some change, 3 is definitely included in this. So this is indeed an actual critical value we have to account for. All right, so then the next step is with the closed interval method is we make our table. Remember, we're going to plug these values into the original function we were given. So we label our x values. We start with the beginning of our interval, include any critical values inside the integral or interval, and end with the end of the interval. Sorry, interval and integral. It's tough for me today. Words are hard. All right. So now we're going to plug each of these 3 values into this equation. So when we plug -1 in, we get 2 plus 4 pi cubed. When we plug pi in, we get 1 minus 3 pi to the 4th. And when we plug 4 in, we get 257 minus 16 pi cubed. So I want to make a comment about this. What we're supposed to do next is pull the biggest value we see here, as name it the maximum, the smallest value we see here, and name it the minimum. Now, that is actually next to impossible to do without a calculator. So I'm going to show you what the calculator approximation of each of these values are. Now, the reason that I wanted to show you these numbers before I kind of continue is because, you know, this is pretty tricky, and this would be hard for somebody without a calculator, right? And it does say on the test you don't need a calculator, and it'll say on the final you don't need a calculator. So I want to remind you, please keep in mind that practice tests and practice problems that we give you, there's sort of two things that you can kind of take to the bank on it. You will commonly see problems that are in totality probably way too time consuming or difficult to put on an actual exam. And the reason behind that, it's usually intentional. And the reason behind that is because in order to really allow you to practice with all the nuance within the topic that we're trying to talk about, we kind of have to give something a little complicated so you can make sure that you're remembering to ask the important questions and look at the important things. And then sometimes the numbers aren't quite so pretty in those situations. So I do want to reassure you that the actual exam is written by a committee of people. They're very good at what they do. They take all of these things into account. They look at things like timing, you know, they make sure that the numbers are doable. It doesn't mean the numbers are pretty, but they make sure that things are done in a way that it's test appropriate, right? So I don't think you would actually see what is happening here on a question like this on the final. I think it would be way more clear or way easier for someone without a calculator to be able to distinguish what is the biggest and what is the smallest number. So it's really the fact that we have pi here and we have these powers of pi that makes this look so nasty. So don't let this problem freak you out in terms of the actual exam. I just wanted to comment on that. All right. So if we look at what we've got here, negative 291 is going to be the smallest number. Positive 126 is the largest number. Now, your final answer must be exact values. You only create these as context because it's, you know, otherwise it might be hard to do this. When you report your answer, do not use these numbers. It clearly states that we want exact answers. So the way we would report our answer here is there is an absolute maximum of, this is the biggest number, but that is the exact form of 2 plus 4 pi cubed at x equals -1. There is an absolute minimum of negative, oops, sorry, I was about to do the thing I told you not to do, of 1 minus 3 pi to the 4th at x equals pi. So since these aren't multiple choice questions, we don't have the added pressure of then selecting the correct one of these numbers out of each statement, but this is what we mean by giving exact answers. So even if you use your calculator to approximate numbers, we still want these exact numbers. That's what we mean by exact answers.